Hey everybody, it's Tony from Adafruit, and I'm back with another fun Raspberry Pi stream. So last week I didn't have a stream. I was actually out at Maker Faire and had a lot of fun out there, but let's get back to it and do some fun stuff. And so for this stream, I thought I would kind of follow up on the previous stream that I did, which was on like simple ways to store data for your like program state or even sensor data as like a comma separated value file. And this time I thought let's kind of start digging into using a database to store data, both for like your program state and for sensor data. You know, maybe we'll get more advanced with it. But let's look at like what a database is, how you can use a database, how you can query it, those types of things. And so we'll kind of dive in and just play with it. And also maybe before I get started too, I also just want to give a shout out to people at Maker Faire that came by and said hi. So thanks a lot. It's really good to get feedback that, you know, people telling me that this stuff helps a lot. So I'll keep making all these cool videos as long as people like it and learn something from it. So basically, so let's dive in. This will be part one. I know I'll definitely do at least 2 videos on this, maybe more. We'll kind of see as I go what kind of data, what kind of information we get into. So okay, let's just dive right into it. Let's go to the main view, and we've got basically just web browser set up in the upper right corner here. So I have the Raspberry Pi, and using my favorite sensor, the DHT temperature and humidity sensor, connected to it right here. I actually have a second one, and we'll see why I have 2 of these sensors in a little while here. So let's just kind of dive in. In this video, what I wanted to do is look at how to create a database, and we'll use a database called SQLite. And you can actually see the web page right here for it, SQLite. Really, really nice little database system that's all stored in a single file. So it's not really complex, and we'll kind of talk more about it. But we'll look at how we can use this and how to use SQL, or the structured query language, which is how you talk to a database. It's basically a programming language that a database understands, and you can use it to do all kinds of things like create data inside of the database. You can query the database using SQL, and so we'll look at that. And you might, if you've heard of it before, you might hear it referenced as SQL instead of SQL. I say SQL, some people say SQL. There's really no right or wrong way to say it, so whatever works for you. So anyways, we'll dive in, we'll look at just some basic usage of how to create a SQLite database, how to store some data in it, and then also some basic Python code to read data and write data to the database there. And the whole idea here is that I have this DHT sensor hooked up, and I'll read the sensor values and write them to the database. And then we'll look at the data inside of there and different ways we can query it and kind of hopefully get a little bit of an understanding of what a database is and what you can do with it. And so like I mentioned, the database we're going to use is called SQLite, and it's a really, really nice piece of software. Basically, it's a self-contained database, so it just lives in a single file. It has all of the data inside of there, but it is a real database system, so the SQL language is pretty complex and supports lots of really complex queries. And SQLite, for the most part, implements pretty much all of the standard specifications. It's actually, I think, a standardized language for SQL, so it's very powerful. There are other database systems, though, so there are things like MySQL or MySQL, PostgreSQL. You know, these are bigger systems, more server-based, so they're meant to kind of run on a machine and support like hundreds and thousands and even millions of transactions per second. You know, lots of users accessing them. Great if you're powering like, you know, a website or something that's getting a lot of load. But for our needs, we're going to keep it simple. You know, there's just a little bit of data. It's just my program that needs to store data. And so we'll keep it simple with SQLite, because you'll kind of see that it's pretty powerful. Even if you have simple needs, you know, it still makes sense, I think, in a lot of cases to look at using a database, and SQLite makes it really easy to do that. And it's something, too, where when I was first learning a lot about databases and stuff, they're a little intimidating, because you start to read a little bit about it, and a lot of things dive into, like, how you create tables and index them properly and join tables and do all these fancy queries. And we're not going to get into that. You know, I'm just going to scratch the surface. I'm not even going to mess with joins right now. So, you know, if you're a SQL pro, this is probably going to be a little bit boring to you. But I really just wanted to show some interesting ways to store data in the stream for this. So we'll kind of dive in here. And I think the first question is, okay, like, what is a database and what can you do with it? And I think an easy way to think about it is to think of a spreadsheet. If you've ever used a spreadsheet program where it's really just a table. So I'm looking at, like, this is Google Spreadsheets. And so you can see I have rows of data here and then columns. And I can say, okay, you know, this column, let's say this is time. And then this is maybe the name of a sensor. And this could be maybe the value of that sensor. And then for each row, I could put inside here and say, okay, you know, maybe the time right now. And I don't know if Google has a way to insert the current time in here, but I don't know, we'll just say like today. Imagine this is like, you know, a Unix time or something like that. You know, this could be like a number of milliseconds since the epoch. And maybe the sensor name here, I just scrolled down, there we go. The sensor name, this could be, you know, maybe my DHT humidity sensor, something like that. And the value could be like, you know, 59.5% humidity. And then there could be another reading inside of here, so maybe, you know, slightly different time. And then this could be maybe my DHT temperature reading inside of here. And this could be like 23.4 degrees Celsius, something like that. So, you know, you have a table, you have rows of data. There's a schema for this data, which really means what are the columns that are inside of this table. So, you know, like if I just had some random value foo right here, what does that really mean? Like, you know, is this just some label assigned to this row? You know, I need to tell you what this is. So I don't know, maybe this is like some comment that you can leave on this data type here. So, you know, think of this row up here as the schema that's describing this table, so that if I sent you this spreadsheet, you could look at it and say, oh, okay, these are sensor readings. And, you know, this column right here is the value of my sensor reading. And, you know, hopefully maybe there's enough info in here. You know, maybe instead of comments, I should say this is the unit of measurement, something like that. So we could say this is like percentage, so we'll say percent, and this could be Celsius, something like that. So it helps describe the data inside of here. And a database is really just a collection of tables like this. So you can define tables, they can have any number of columns. Those columns can have different types of data. So the nice thing about a database is that it enforces some structure on your data. So you have to kind of figure out, okay, I have sensor readings, and you know, what is a sensor reading? So in this case, in this table here, a sensor reading is, there's a point in time, like some time associated with it. There's a name which kind of describes maybe what that sensor is. There's the actual sensor reading value itself, and then maybe a unit that I also have associated with it. So, you know, I have to kind of think about, for all of my readings, what's the data that I need to describe it, and then I need to kind of map that into a table form like this. So I need to figure out, like, what are the columns that I have for this, and so that's what I put up here. And then when you use a database, you also need to think about what's the type of data, because we'll kind of see databases have different types for the columns, and you need to be explicit. You need to kind of say up front ahead of time, you know, this column is this type of data, and the database will actually enforce constraints for you. So if you say a column of data is a number, you know, this can only be integers, for example, and you try to put like a floating point value inside of there, it'll actually fail. It'll say, no, I can't insert that data. Which is a good thing, because that lets you encode a lot of what you might call your business logic, or, you know, your rules around what a sensor reading is or what anything is, because really you can represent almost any kind of data and put it into a database. But you can have those rules enforced by the database itself, so that can simplify your code. You know, you put more of that logic into the database, so the database knows, okay, I'm only going to store these types of data. You know, these are the values or the types of data that I can store inside of here. And if I somehow try to insert some row of data that doesn't match the format for it, it'll just stop me. It'll say, hey, this is bad data, which is good, because that prevents the data from getting stuck in the database, and then later on your program reads it, and suddenly maybe you get back like a text value for your sensor reading here, where you expected to get back like a numeric value that you could compare against, you know, other values with, and then maybe your whole program explodes because you never thought when you were coding it that you would get back a value like that. So that's one good reason to use a database, and that you can put some of that logic, you can let the database enforce some of your business logic. Another good reason is that databases have a really complete system of querying the data. So when you're looking at the data in a spreadsheet like this, you know, it's a little hard to say. I mean, imagine if I had thousands of rows inside of here, and I just wanted to view like the humidity measurements inside of here. You know, there are all kinds of wacky syntaxes in spreadsheets. There's lots of functions you can do in here. I don't even know what the Google spreadsheet functions are, you can probably filter some of the rows. Like if I click this, maybe it's got like a filter inside of here. I don't even see that. I'm sure there's a way to do it. I know Excel has stuff like that. Actually, this thing might be a filter. Yeah, there we go. So you can like create some kind of filtered view. This gets really complex. It's like, okay, I need to know how to use Google Spreadsheets. The nice thing is with databases, so they use the SQL programming language to query the database, and that's a standard. There's a standard way to write a query. So you can actually write a query as text that says, okay, I want to select all of the rows from my sensor readings where maybe the name is my DHT humidity sensor. And then it can instantly, well, almost instantly, return back all those results to you and just give you a list of, okay, here are maybe the 10 sensor readings that you wanted, like the humidity measurements. And so that's a pretty powerful thing. It's useful just for me as a user. I can go in and, I can think of all kinds of advanced queries. You can chain things together and say, okay, I want to query maybe the humidity sensor readings that were made in the last minute. So you can have, extra conditions that you add to those queries. And so as long as you can convert your query into a SQL language command, then you can run that query and get the data back from the database. And if you can do that manually, then your program can also do that too. So you can write Python code that talks to a database and says, okay, hey, give me all the sensor readings for maybe this period of time or something like that. And it'll, you can have a few lines of code that run that query and then give you back the results. And then your program could do something with that. Like you could build a graph, or you could save that to a file, or maybe take certain actions. Like if a sensor goes above a certain value, then maybe you do something with that, based on that condition. So gives you a lot of power and flexibility, because if I had a Google spreadsheet document like this one, and let's see, how do I get out of this filter view here? I don't even know what's well, I clicked something. So but anyways, how could I programmatically control this database? It's not really easy. I think there are some Python libraries to deal with Google spreadsheets, but it's not going to be nearly as easy as using a database system where it's built to allow programs and users to query it in different ways. So we'll just kind of dive in here and get started. I'll show some basic examples of how to install SQLite and start using it. I should also kind of say, if you're interested in learning more, like I said, I'm really just going to scratch the surface. We're not going to get too deep. You can go pretty deep into understanding SQL. I mean, like some people, their entire full-time job is, running databases and building databases. And so it is a large subject area, but don't be scared by it either. Like you can learn enough to do interesting things with it. But I just wanted to recommend a couple interesting resources. So this is an interesting book, the Learn SQL the Hard Way, and it's still kind of being written. Really cool book. I skimmed it. I haven't really read it, but it looks like a great little kind of resource to just start from ground zero and learn basics of SQL, like how you create databases, how you model data, how you query databases, that type of stuff. Written by a guy named Zed Shaw, who's done a bunch of books like this. So he's like Learn Python the Hard Way. I really like these books. I think these are really cool. He kind of takes the stance of, you really need to read these and absorb them, and they have a lot of lessons where you go off and you try things, and you do it until you kind of learn it. And it's not going to be like an overnight thing. I mean, I think it kind of says, it might take you months to learn it, might take you weeks if you're familiar with it. But don't let that kind of intimidate you either. I mean, it's you can still skim this and get some good info. But I think this looks really good. I think it's worth checking out. It dives into a lot of good detail. Like if you look into the table of contents here, let's see. Well, I don't know. We'll just kind of go through here. I mean, it goes into great detail. So check this out. And by the way, I'll put links in the description below when this is up on YouTube. So look in the description and you'll see links to all these. The other funny thing, so this is a pretty cool book. It's called The Manga Guide to Databases. I bought this for a friend who is a master database hacker, almost as a joke for a birthday gift. I thought, oh, this will be funny. He'll get a laugh out of this. But I was thumbing through it, and this is actually a pretty cool book. Like, it's serious. It actually uses manga, like Japanese animation, to teach you databases. And I'll just kind of scroll down. I mean, it really is. It is a manga. I think there's like a database character in here, but it's worth checking out. It's not super expensive, and I thought it was cool to read it. I think it's targeted more at people that are learning, beginning programming, stuff like that. But worth checking out. I think it's kind of cool. Don't be put off by it's not a kid's book. It actually does teach you some stuff. So check both those out. I mean, those are probably enough to get you started and start learning a lot of things. But like I said, so SQLite is what I'm going to use to do this kind of series. And like I said, it's a really nice self-contained database, very high quality. I haven't really looked at the code, but I've heard from multiple people that the code for SQLite is really nice, very well commented. I've heard the author on, I think, a couple podcasts, or maybe I saw some videos of like different programming conventions. And seems like a really great person. It's really amazing that this is, open source software that's just out there. Because for a long time, I mean, database systems are complex and expensive. If you want to buy like SQL Server from Microsoft, it can be tens of thousands of dollars sometimes. Or you can use something like SQLite. Now, granted, you're not going to get the same level of performance and support and stuff like that, but it's cool that you can do all these things with open source software like this. So we'll use SQLite, and I'll just kind of dive into my Raspberry Pi. I'll show you how to install SQLite, and we'll just do some basics of creating a database and querying it inside of here. So I'm connected to my Raspberry Pi with SSH right here. And so I'll show you first of all, to install SQLite. So SQLite itself is really just a library. Like, it can talk to a SQLite database, and it can query it, it can write data to it. And then there are wrappers that are built around that. So there are like command line tools that you can use that give you a little text console. And there are also GUI graphical tools that you can use to query SQLite databases. And I'll look at one of those also too. But it's not like a server or a system that you need to run. It's usually embedded inside of a lot of programs. They can include SQLite and link to it directly and use it for their data. And the really nice thing is with Python, it actually has in its standard library, of course, batteries included, it's got everything, SQLite support. So you can read SQLite, you can query SQLite databases really easily in Python. So, okay, we're connected to our Pi, and of course you always want to do apt-get update, run this command. It's going to update all your packages. I'm not going to run it because it takes a second to do it. And then after you do that, you want to do install SQLite 3. And so this is going to install the command line tools for SQLite. I've already installed it, so it's already there. And once you've installed this, you can actually just run SQLite 3, and this will give you a little console. So it's kind of like Python, where if you run Python, it gives you this interactive shell where you can execute Python code inside of here. So you can do that exactly the same with SQLite here. And you can do, I think, .help and say, okay, this will tell you the different commands you can run. Now, these aren't SQL commands that you're running yet. These are actually just sub-commands for this tool that's querying SQLite. And I mean, this lets you kind of say, like, if you want to open a specific database file, there's a command for it. If you want to quit, there's the .quit command, and that lets you exit out of here. So, we'll get to SQL here in a second. But the way you probably want to run it is you want to point it at a database, and it'll either create a database or open an existing database. And the database is just a file. You can give it any name. Usually they end in .db or .SQLite. So let's just say SQLite 3, and we'll say, how about dht.db? Because we'll make a little database to power this DHT sensor system that I've got going here. And so it starts up, and there's really nothing in the database initially. And so the first little SQL command that I'll show you is how do you create a table. So just like I was creating a table in the spreadsheet here, I want to create a table inside of my database. And so the table is just a schema or a structure that says, hey, the rows of data can live inside of here, and they have these columns. So I need to really describe, like, what are the columns of data that can go into this table. And I'll put a link in, because one really important thing when you're thinking about, when you're creating tables and modeling data, you need to understand the types of data that you can have in a column in a database. And I'll put a link to this page, really handy page. The documentation, by the way, for SQLite is really outstanding. Very good detail. It's awesome. So definitely check this out. But this mentions, these are the basic data types that you can have inside of a table in SQLite. So you can have an integer column, which is just like a number like 1, 2, 3, 4. You can have a real number, so this is like a floating point value, like 10.3 or some numeric value with a decimal point. It could be an integer also inside of there. You could have a text column, which is just a string of data. And then you could also have a blob column that's basically just like binary data. So if you wanted to store like an image or something like that. Now the SQL language also has a bunch of other types that it defines, but SQLite, it's light, it has light in the name. It doesn't implement everything, but it does map some of these standard SQL types into these basic types that it supports, and it does that kind of automatically. So there's a really nice table in here that kind of says, okay, these are maybe standard SQL types that you might see. and this is how SQLite actually stores it internally. And so you can see there are more types in here. There are things like date types and time types inside of SQL, and it'll store them internally as like a numeric type. And it talks about too also different things like if you're using date types, let's see, I think they talk about it up further above here. Well, maybe they don't mention it here, but basically date types, there are all kinds of little functions. So they mention like their date and time functions you can look at, and we'll look at those. We'll see when we do some queries here of how they're important for it. So, okay, so first of all, to start with, there's nothing in our database, so I'm going to create a table, and maybe we'll just create a test table. And so the way you do that, and the syntax for SQL, it's just text. There's not a lot of kind of, I don't know, junk to it in the sense of, there's not like curly braces and all kinds of stuff. It's actually pretty readable. And so we'll say create table, and then we need to name the table. Now I'm doing all this in uppercase, but you don't have to do this in uppercase. You can actually do lowercase for all of this. You see a lot of conventions in SQL code where it's all in uppercase, sometimes because that code might be mixed in with other programming language code, like your Python code might have a SQL query inside of it. And so sometimes it's easier when you make it uppercase. It makes it more explicit that this is my SQL command that I'm running. But I need to give this a name. So let's just call this the test table. And then you give parentheses here, and inside these parentheses, you need to list out all of the columns that will be inside of this table. And each column has to have a name and a type associated with it. So I don't know, let's, this is just a test table. So let's give maybe, we'll create a column called name, and this will be a type text, and then we'll do comma, and then how about value? We'll say this is the column name value. And we'll make this a real type, so this can take like a floating point value. And then, I don't know, how about count? And we'll say this is an integer inside of here. And then you want to end the statement with a semicolon. And so after I do this, oops, oh, I put a comma at the end there that I didn't mean to do. This might have done something messed up. So I combined, so basically what happened here is I accidentally had this extra parenthesis. It got confused, and so it continued on here and said, I'm waiting for you to finish this statement. And then I put the statement again, and then it got really confused and said, wait, you've got two statements here. So the nice thing is you can just press up and it'll give you back the previous thing you entered. So let's try that again. Oh, well, okay, I probably just created the test table. I did something kind of funky there. So let's recreate it. Let's call it test 2. Just because, I might have put test into a weird state with that. So anyway, so I've got a table called test 2. So, okay, so that's how I create a table. And, if I wanted, and you kind of notice there, once the table is created, I can't create it again. You can actually drop a table. So I can say, if I want to delete the table, I can drop table test. And again, I have to end with a semicolon. And so that'll drop it. And now I actually should be able to create table test again. So if I do that, then now you see that that succeeded again. So, okay, I can create tables, I can drop tables. Now, if you want to query a table, there's a select statement that you want to use. And so select says, okay, I'm going to query a table. Now you need to tell it basically which columns do you want to read from this table. So, you notice that I created this table and I added 3 columns. And so I can basically say, okay, let's select maybe column name and value from this table. And then I need to tell it, okay, which table am I querying? So I'm going to say from, that's the SQL syntax, and then the table name. So we'll say table test, and then semicolon again. And this doesn't return anything because there's no data in this table yet. But this is kind of the basic syntax. And there's a nice little shortcut. If you just want to get every single column, you can do select star from your table name, and that'll give you everything back. So, okay, and then the next command that you're going to want is probably how to put data into this table. And so the insert command is what you want to use for this. So you do insert into test values. So values is just part of the syntax. And then in here you put parentheses, and then you list out the value for each of the columns in order. So it's going to match up. If I can put 3 values inside of here, I need to start with the name, the real, the value, the floating point value, and then the count. So in here, let's just say foo and put single parentheses here, foo, and then my value, I don't know, let's say 42.42, and then count we'll say is 1 for this, and then semicolon to end that. And so this is going to spin for a second, and then it inserts it. And let's run it again. Let's put another row in here. So let's just say like bar, and then maybe this one is, how about negative 20.56, and then we'll say count is 2. So okay, so now I have 2 values. Now let's run this select statement again, and let's see what we get back. So I'll do select star from test, and look at this. So I got back both of the rows of data that I just inserted here above. So you noticed, I did these insert statements, I run this select, and it gives you back both rows. And now it kind of gives you a format here. It's doing like a pipe character to delineate each column. So, it's maybe not as readable as a spreadsheet, but if you're running a program, for example, it can delineate, it can parse those characters out inside of here. Now, the select statement is really powerful, and I highly recommend checking out the resources like I mentioned, some of these books about how to use SQL, because you can actually do much more than just listing all of the rows. So, for example, let's select star from table test. There's a where clause where you can actually filter. So I can say, let's say where name equals foo. And so let's see what this does. So notice this only returned 1 row of data back. And so it actually went through all of the rows of data in the database. Just imagine like you're looking at a spreadsheet and you're looking at each row, and you're looking at the query that someone gave you, and they basically said, hey, give me each row where name equals foo. And so you go through each row and you see, okay, what's my name? Oh, this is DHT humidity. Nope, that's not it. Maybe there's a row down here that has foo. And you say, okay, that's the one. I'm going to pull that row out and print it out here. So that's all the database is doing. It's just taking this query and figuring out how to look at all the data and see what matches it. It's a little bit weird. It's a little bit different, especially if you're used to programming, something like Python, where it's a very procedural format where you kind of say, okay, loop through every row and check and see, is this column this value? Right here, I'm kind of describing, I'm saying, this is the output that I want to get. I want to get all the rows where name equals foo. I don't care how you do it. Database, do your magic. Like, it could be doing all kinds of number crunching and processing, and it is actually pretty fascinating how databases are implemented. Internally, they use some pretty cool data structures to do like fast lookups and queries of things. But ultimately, at the end of the day, sometimes they just need to go through row by row and see, what data matches this query, and they give it back to you. And this is really powerful, and this is why a database is interesting, because, I don't need to write that code myself. If I have a whole collection of sensor readings in a database, I'll just tell the database, hey, I want all the readings in the last hour, or I want all the readings from the DHT temperature sensor. I can turn that into a select statement query, send it off to the database, and it's going to give me back all those results. So I don't need to write all that code that says loop through all the data, figure out, if it matches some condition here, because, I'm not going to write code that's going to be nearly as fast or as well optimized as something like SQLite that's been around for years and had lots of contributions, and, it's pretty battle tested. Maybe with years of study, I might be able to write something that's barely as fast as it. But if someone else has done the work, I'm gonna use it here. So that's a really powerful thing. I mean, you might look at this and think like, this is really complex. Like, I need to run these commands to create tables, and like, I'm just storing sensor readings. Why does it have to be this hard? And the idea is that, even though this is a simple example, you can scale it up. I could have hundreds of columns. I could have multiple tables. I could have millions of rows of data. And, as long as I'm writing good queries and sending them to the database, I can get this data back, and the database can take care of making it fast and efficient to deal with this data. And, the database systems beyond SQLite, things like PostgreSQL and MySQL, those systems are, much more optimized. They can handle lots and lots of queries and things like that. So you can get great performance without having to learn all the details of, storing data in the most efficient way like this. That said, you can also shoot yourself in the foot. So, you do need to be careful. Like, if you model data in a bad way, that might make you, jump through a lot of hoops to query your data. That might be a little confusing. Like I said, we're just kind of scratching the surface of some of the data here. So, okay, so that's how I create a table. Let's drop this table again. So let's drop table test, and let's also drop table test2. And I'll show you also, when I drop the table, I can't query it anymore. Oops, I misspelled that. So we'll say drop table test2. So now if I run that query again, it says, hey, you have no table here. Okay, so what I wanted to do, I wanted to create two tables. So I'm going to create one table where I'll store sensor readings, and then another table where I'm actually going to store the sensors that I have connected to my Raspberry Pi. And so this is kind of cool because I'm going to put my program state, which sensors I have connected, what pins they're connected to, into my database, so that if I want to add more sensors, I can just add new rows to my database. I don't need to go change my code or change some configuration. I could have a completely separate tool. Maybe I have some little graphical menu that I use to say, hey, I added a new sensor here, and plug it in, and it just saves a row to the database. And then I have another script maybe that's reading that database and actually measuring the data with the sensors. And so that's a powerful thing, that the database is the truth of my program state. It has all the knowledge of how my program is configured. And so multiple things can read and write to that database, and they don't all have to be like kind of tightly coupled to my program state. The database is the truth of my state. So, okay, let's create a table then. Let's create a table. Let's call this my, let's create a table for my sensors. So this is basically, I have two sensors connected to this Raspberry Pi. And for a sensor, I need to give it a name. I need to give it a type, because this could be a DHT22 or maybe a DHT11 sensor. I just happen to have both DHT22 sensors here, but there are multiple different types, or maybe it's not even a DHT sensor. Maybe you have something like a TCS color sensor or something like that connected to the Pi. So, again, think about how you model that data, and think about, what is a sensor. Like, not every sensor is a DHT sensor, for example. But okay, so I need to think of my columns here. So I'm going to give this a name. Like I said, this is the name of the sensor. We'll give this a text type. I'm going to give this a type. So this is the type of sensor. Like I said, this is a text type also for this. And then I think that should be about it for the sensor. Oh, no, sorry, the pin also. So I need to give the pin that this is connected to. So like this DHT sensor over here is connected to pin 18, and then the one up above here I've connected to pin 25. And so the pin, in my case, I'm just going to say this is an integer because it's a number. It's, it can't be like a floating point value in this case. So, okay, that'll be my sensor table. And then let's create another table, and this will be for my readings. So each of my sensor readings, and we'll call this readings. And so let's think about, what is a sensor reading? So a sensor reading probably has a time associated with it. So I want to look at time series data. I want to look at how sensors change over time. So we'll give a time, and there's a date time column you can use actually that really gets stored as a number internally, but I'm going to give it a date time type, for now, just to be as descriptive as possible. And inside of here, I'm actually just going to store the Unix timestamps. This is the number of seconds since January 1st, 1970. Really common way to store time, like with pretty good precision, up to second precision. And the nice thing is, like, it's just a number. It's it's a big number in the tens of millions or so. But okay, so I have time. I have a name associated with this, like which sensor made this reading, and so we'll give a name here, and this is a text value again. And then I have the actual sensor reading itself, so we'll say value. And for this, we'll make this a real type, so this is a floating point type inside of here. And so we'll save that. And okay, so now I have two tables inside of here. And now I'll show you something kind of cool. So I've been using this little GUI, not GUI tool, I've been using this little console tool. Let's look at a GUI tool, a graphical user tool, to look at our database. So I'm going to quit out of the SQLite console tool. Now this database still exists. If I list all these files, here is dht.db, and so it's still there. But let's look at a tool. So I'm going to look at a neat tool called SQLite Studio. And this is one I just searched around and just looked for a cross-platform SQLite tool. There are lots of tools like this out there. This one seems to support all the platforms. So I'm going to try this one out. And this, you might find this a little bit easier. So I installed it, and I'm just going to run it. And it's, let's see, it takes a second here to start up. And then I'll pull this over here so we can kind of see it. And we'll close that, I don't need it. So it starts up, and I need to connect it to my database. I need to open my database, basically. And I'm going to basically, you need to tell it the type, so this supports different types. SQLite 3, I need to point it at my file. And then this is actually connected to my Raspberry Pi. So if I go down to my Mac, I'm using that tool called Mac Fusion. Mac Fusion, really handy tool to mount your Raspberry Pi as an SSH file system. So I've got my Raspberry Pi, and then here's that dht.db file. So we'll save that. And then I'm just going to uncheck this permanent. It can actually remember your databases, but I don't really care in this case. So we'll say OK, and it opened my database. And if I double click this, you can actually see, like, here are the two tables that I created. So here's my readings table. And you can actually look at, okay, these are the columns inside of this table. And so it's, here's my time column, here's my name column, and here are the types inside of here. And I can modify these. If I wanted, I can add a new column inside of here. At least I think I can. I think there's a add column if I wanted inside of here. So you have to tell it the type and things like that. Now you might see some of these things in here like primary key, foreign key, constraints. Don't worry about those yet. So, we're not going to get into this in this video. Maybe a future one we will, but these are really powerful things you can do in a database where, you can describe like this column is a primary key, which means that its values are unique. Like for example, with a sensor reading, maybe the time and the name of the sensor, like both those values together uniquely identify that sensor reading, because, if I couldn't have two readings at two different readings at the exact same time from the exact same sensor. That doesn't seem like it would be possible. I mean, maybe it could be possible if you have some wacky sensor that has multiple readings, but that doesn't really seem like it makes sense. And so the concept of a primary key is you can kind of say, okay, this column or even multiple columns are the uniquely identifiable parts of a row of data, and no other rows inside of this table can have that same value. Only one row can have that value. And the reason you might want to do that is actually for performance reasons. So the database can optimize things and make it faster so that it can quickly look up and say, oh, you're looking for this sensor reading at this time, and because that's a primary key, I can give it to you really fast. But like I said, don't worry about it just yet. We're just thinking about databases as tables and like spreadsheets. I just have columns of data. I'm not getting into how they relate to each other yet, but that's a whole other really cool, powerful part of SQL. But okay, so here's our database. We can look at the data inside of here, and it's actually empty. The cool thing about using a graphical tool like this, though, is that I can actually add rows of data. So if I wanted, I'm going to add a row right here. So the time, I don't know, we'll just put in a numeric value like 1, 2, 3, 4, something like that. Name I can say is foo, and then my value here will say, well, let's test it out. Let's say I put foo inside of here. Let's see what happens. So I hit enter. Now this data isn't saved yet because a lot of databases use what's called a transaction, where you can basically queue up a bunch of changes. Like I'm going to add a lot of rows, and then you apply them all at once. And if one of them fails, everything fails. So it's a good way to make atomic updates. And so you might hear atomic a lot when you hear databases. And that basically means that when you change something, you change it all or you don't change it, anything at all. So like, let's say I wanted to change a row, and I wanted to change maybe the name inside of this row, maybe name and time, for example. But in this row, this value I put is a bad value. And so I'm going to click this checkbox. This is going to try to apply this transaction, and we might actually see what happens here. So it should fail, but oh, that's interesting. It didn't fail. So okay, well, maybe this is a bad example. Unfortunately, I was hoping that this would show, because I tried to save a text value inside of here. If we look at my schema for this column, for this data, it's a real type. So this should fail. Although I'm remembering now that actually SQLite I don't think enforces a lot of these constraints, so maybe bad example. But ultimately, in a lot of database systems, especially bigger databases like PostgreSQL and MySQL, they do enforce those constraints. And if I tried to add a row that had maybe a text value inside of here, that would fail. And then it wouldn't actually write anything else in the row because, either the entire row gets committed or nothing gets committed in this case. If there's one bad part in this row, the whole thing doesn't get added, which is good because that if only part of that row got inserted, if it only had like the time and the name inside of there, that could really screw up your program later when it gets that data back, because it's going to get back a row that doesn't have a value inside of it. And then how do you interpret that? That you might get something that you don't understand in that case. So just something to be aware of, that the data and the types that you have and the constraints that you have on that are kind of important about how you add the data here. But so anyways, I can add rows to this. I can just make up some data here, You can say bar, we'll say this is 10.2 inside of here, and then I need to click this checkbox basically to commit this data inside of here. Interesting, I think this basically saved this as text, or for some reason it doesn't have it as a numeric value. But anyway, so I've saved a few values inside of here. Let's go back to our Raspberry Pi and let's just see that we can see this data using the SQLite tool again. So I'm going to run SQLite on the same database file, and let's just do select star from the readings table, and let's see what we get back. So hey, look at that. We got both of our values back here. So kind of cool, again, like I have two different programs talking to the same database. They both see the same database, the same data. So, it's one spot that has the truth of my program inside of here. So this GUI tool is really handy. It's worth checking out. Really good way, like once you have some data, you can query, you can look at it. You can run queries in here also. So if you click this icon right here for the SQL editor, then I can just run a query just like I'm running the query inside of the SQLite tool here. So if I select, how about let's just select the name from my readings column inside of here, and then I can just click this little run button, and you see it just selected that name column inside of here and gives you those results back. You can also do, you can export this data, you can export the results of this query as like a CSV file. So really handy. This is a good kind of interface. Maybe not an interface you'd want to give like a non-programmer, but if it's just you querying your data in a database, something like this is perfect. Like it gives you the data, you can save it, you can make complex queries and go crazy with it inside of here. So okay, let's go back to our readings and let's just delete these two rows of data. So I'll click this delete and I'll click this delete. And again, I have to click this, basically this commit to say, okay, I've deleted both these rows and now apply that to my database. And just to show you, like I'm gonna go back and we'll run this same select query, and now we see, hey, we get nothing back. So, that database was updated inside of here. So, okay, cool. So let's quit out of SQLite and let's get to some code inside of here. So let's actually look at how do we write some Python code to read our data from our database and read our sensors and then store those sensor readings into our database here. So I'm going to go to, this is my text editor. It's connected to my Raspberry Pi, and so I'm going to create a new file inside of here, and we'll just call this dhtread.py. And the really nice thing, like I mentioned before, the Python programming language has built in a really nice SQLite library, so you can just in a few lines of code open up a database file and start writing queries effectively and getting data back from that query here. So I'll put a link to the description below. A really nice little overview in the Python library here of using SQLite inside of here. So this is what we're going to use. And so let's just kind of start with, let's just print out the data in our database, like our sensors that we've configured inside of here. So first I need to import the SQLite 3 module, the standard module that Python uses. And I'm just going to copy out the code that they have here. So, you create a connection to a database, and you need to give it the name of your database. So in this case, we'll call this dht.db. And then once you have a connection, you have to create a cursor object. And so that's what this line does right here. And so the cursor is just because when you run a query like a select statement, it returns multiple rows of data, and you might only get like you might only look at like one row at a time. And so the cursor kind of remembers where you are in a query, and if it lets you kind of page through the results of that query. So it seems a little weird, but it's a convention you see in a lot of database systems when you're querying them. So once I have a cursor, then really I just can use this execute function and give it raw SQL commands. So just like I was typing into the SQLite console tool here, or even in the GUI tool, I can give it a string that says, hey, run this select statement, or run this create table statement, or run this insert statement inside of here. So let's do that. Let's run a command. So let's do execute. And let's do select, how about select star from sensors? And I don't actually have to give it the semicolon here because it kind of knows that I'm running one command at a time. So I'm just going to leave it off. But you could put a semicolon here, and you could actually have another command after this if you wanted. So we'll do this. Now, when you run a select statement, this will actually, it won't really return anything immediately. The cursor object will basically get the results, And so a select statement returns rows of data, and so you can iterate through those rows. You can loop through them basically. And so in this case, let's loop through them and we'll just print them out. So let's do for each row in C. This is a nice little syntax in Python where if I give it an iterable, like my cursor object, it can loop through all of them. So it'll know when it gets to the last row that was returned that that's the end and that it won't finish, it won't continue on after that. And then let's just print out each row that we get back. So we'll just do that. And let's save this. And we'll go back and let's see, make sure I've got the script inside of here. So DHT read. So let's run Python 3. Oh, and by the way, I'm using Python 3. Just in general, I'm trying to switch to that. So if you haven't installed it yet, just do sudo apt-get install Python 3 and Python 3-pip. Run these two commands and you'll get Python 3 installed, and then you can run that for yourself. So we'll run Python 3 and let's do dht read.py. And so it doesn't do anything. So that's because our sensor table is empty. So let's go back to our little GUI tool here, our SQLite Studio, and let's add something to our sensor table here. So remember, we created this. Each sensor has a name, has a type, and then which pin it's connected to. So let's go inside of here and let's add a row. And so for the name, we'll call this DHT1. This will be maybe this sensor right here. And the type of this sensor, we're going to say is a DHT22 sensor. So we'll give it that. And the pin it's connected to is pin 18. And so let's save this data. So it just committed it to the database. And let's run our script again and let's see what happens here. So cool, look at this. We got a tuple back, or a tuple. So there are 3 results right here. So this is each of the rows from our database query. So this is the name, this is the type, and then this is the pin. Now, when I write a query, I like to be a little more explicit. You know, this star syntax is nice when you're just kind of querying the database yourself and you don't really care and you just want to get everything back. When you're writing a program, you know, I'm going to make some assumptions in the order that the data comes back in. You know, I need to know that this column right here is the name and this one's the type. So I'm going to be explicit and I'm actually going to list those out. So like, let's just say name type, for example. So let's save that and let's run our program. And then we should see, okay, now we only get the first 2 rows back, but I actually want to get also the pin number. So let's save that there. And so this is just nice that, like, if in the future I added more columns to this table, you know, I wouldn't get them back and then maybe unexpectedly break my program. You know, I'm only asking for the columns that I'm going to use here. And so when I run this, you know, I get the same results back here. So that's cool. So, okay, so my row object is a tuple. I can actually unpack this tuple. So I can say name, we'll say DHT type, and then pin equals row. And so what this will do, really nice little syntax in Python. If you have a tuple, which is just a collection of values like this, you can assign the values inside of that tuple to different variables here. And so now I can say, okay, let's just print out found sensor, and we'll print out the name of type, and we'll give it the type here on pin, and we'll give it the pin, and then we'll use the Python format syntax, and so we'll give it name, DHT type, and then the pin number. And so now when I run this, we can get back and see, we get back to syntax here. So I must have missed a parenthesis here. So yep, there we go. So we save that, and then we run this, and we see, okay, so now we found a sensor DHT1, or name DHT1 of type DHT22 on pin 18. Okay, cool. So you can imagine, you know, if I had multiple sensors, I can just list each of those sensors in my database here. And then when I run this script again, it's going to pick up that new sensor. So really powerful thing where, you know, my program is reading from the database its state, like how it should be configured. And then when I want to configure it, I can just add to the database. And so, you know, it might be as simple as me manually running SQL commands to insert the rows into that database, or I could go build some complex graphical application that walks me through how to add a sensor. You know, really the sky is the limit as far as how complex you want to make this. But it's nice that because I'm using this database, I've got that flexibility. I can make it as simple or as complex as I want, and the database helps me in both cases with that. So, okay, cool. So I found my sensors. Now let's configure them. And so we'll look at the Python DHT sensor library. And by the way, there's a guide that we have that tells you how to use this library, how to install it. I'll put a link in the description below. So you'll need to install this library. I've done it ahead of time on my Raspberry Pi. But I'm going to look at one of the examples from inside of there. So there's this little simple test example. And so I'm just going to copy out the code for how I use this sensor. So we'll just copy out the import statement that I need. So we'll import the Adafruit DHT library. And then now here, okay, so I'm printing out the sensors that I found. And then let's save the sensors also in a list that I can use to read them later. So let's just create a sensors list, and we'll make it empty to start with. And then after I find a sensor, let's append it to my list. So we'll say append this to my list of sensors. And then inside of here, I'm actually just going to append a tuple that has all of the values I parsed out. So name, DHT type, and the pin. So that later on my program can go and read these sensors again and read them. So okay, so we'll save these values. Now one thing I need to do in my library here when I read, so basically it's this DHT read retry function that I need to call, and I need to tell it the type of the sensor. So this actually has like a DHT22 type up here, and the pin it's connected to. So I've already got my pin number, so I know that like which pin my sensor is connected to. Now for this type, it comes back from the database as a string right here. So the database doesn't know about this Python type. Like in Python, for this library, I want to use this type right here. It's actually just a variable value. So I want to use this DHT22 value. And so I need to do some conversions here. It's not really the prettiest code, but it works. And I'm hoping in the next video, we're going to look at something called an ORM, an object relational mapper, which is basically a way to write Python code that describes a database. So I can say, okay, you know, I need to store this type of data, and here's a Python class that represents it. And then it will actually go and create the tables, it'll create queries, you don't even have to write SQL to do this. So a lot of this complexity can be hidden and taken care of with those systems. But for now, we're just dealing with raw SQL. And so I need to kind of convert from the data I get from the database, which is just text, into the data that my Python program cares about. So it needs some special enumeration value. And so I'm just going to do that with an if statement. So I'm going to say if my DHT type equals DHT22, then I'm just going to change its value to equal my Adafruit DHT library.dht22 value. And then let's do an else if my DHT type equals DHT11, so this is a different type of DHT sensor, then my DHT type equals Adafruit's DHT.dht11. So, you know, I'm just converting from the string value in the database into a value that my library expects. And then it's probably smart, I'm going to put an else in here. So if I get some value back that's not DHT22 or not DHT11, and it has to be exact, it has to be, you know, uppercase. If it's lowercase, it's not going to match. Then what I need to do is say, you know, if I get some value back that I don't understand, I'm going to throw an exception. So we'll say raise runtime error. And it's funny, I don't know if you guys can hear it, but I have an Amazon Echo in another room, and for some reason it just turned on. Something about what I was just saying, I think it's giving the weather or something like that. So anyways, that's the smart world we live in, when your smart devices get confused and start yelling at you. Okay, anyways, so let's just raise a runtime error that says, hey, unknown sensor type. And then let's put the value inside here. So we'll say format, DHT type. And man, boy, Alexa is really mad. She's like going on about something. I have no idea what she's talking about. So, okay. All right, so we'll save that. And then let's, okay, so that should be okay. So now, oops, I don't want to delete that parenthesis. So, okay, so now, you know, I'm going through all the rows in my database because I ran this select statement. I'm converting from the strings that I get back in the type column here to the types that my library cares about. And I'm just saving those back in my DHT variable here. And then once I have those, I'm adding them to my list of sensors here, and I'm just adding them as a tuple. So let's just let this run, and then let's print out this sensors variable just so you can see what this is going to get inside of here. So let's run our script, and let's see. Oh, so I deleted the 2 there. So yep, there we go, DHT22. So let's run this now. So okay, so now you can see it printed out and said, okay, I found that row of sensor, I found my DHT22 sensor here. That's this line right here. And then the next line here is where I printed out the list of sensors. And you can see where, okay, now, I have my name. So that's this name value here. My DHT type, this is kind of interesting. It's not the string DHT22 anymore like you saw. It's actually the value 22. And that's just what this variable maps to in the library. So that's why you see that value. And then my pin number 18 here. So okay, so that's cool. So I've got those values back. Now let's make a loop here to read this sensor based on that data. So let's just do while true. We'll just loop forever. And let's do a sensor reading. So let's use this function here from our DHT example. And we're going to say, so first of all, actually, I need to loop through all of the sensors inside of my sensors list. So let's go through, for each sensor S in sensors. Then I can actually do a reading for it. And again, I'll use that tuple unpacking syntax, really handy in Python. So DHT type and pin equals S. So this is just going to it's going to unpack this set of tuples here and give me unique variables that have these names inside of here. So okay, so now I can actually do this reading. And so now I need to give it my DHT type, and then the pin matches the pin number here. I'm not using the name yet, but we'll get to that in a second here. So let's do the, oops, I hit the wrong key. All right, we'll save that. And then let's just do a time.sleep. So we'll wait 2 seconds in between sensor readings here, just because the DHT sensor only reads new values every 2 seconds. So you're not going to get a new value if you try and read it faster. And then I also need to import the time library to get this. We'll say import time, and actually let's just separate the, I like to, the PEP style, PEP8 style, basically your standard libraries come first as imports, then a blank line, and then other libraries that you have installed that you're using. I try to follow the convention. It's kind of nice. It makes it a little bit easier to read in your code. Okay, so we'll do that. And now when I run this, I get an error. So error accessing GPIO, make sure to run as root with sudo. And yeah, when I'm using this DHT sensor, I have to run as root because it has to access the GPIO pins really fast using memory mapped IO, and you have to be root to do that. Even on the latest versions of Raspbian that let you access GPIO as a non-root user, the way this library works is it actually has to access the raw GPIO registers, and to do that it has to be root. Like the kernel has to trust this code. So okay, so we found our sensor, and we should hopefully be getting a reading back here in a second. I'm not printing the reading out, so maybe I should print them out. So let's add a print statement here. So we'll say my sensor, and let's give the name here, and we'll say humidity equals, and we'll give our value, and then let's do 0.2f. This just means print, I expect a floating point value and only print the first 2 values after the decimal point. Search for Python string format language, and you'll see all the syntax for this. Lots of handy things you can do here. So here's the % of humidity, and then temperature equals, and we'll say the same 2 decimal places, and this is going to come back in Celsius, and then our format string. So let's give the name of our sensor, the humidity value, and then the temperature value inside of here. So okay, so let's save that, and now let's run our program again, and I should hopefully see, there we go. So there's our humidity sensor, and you see every 2 seconds it's giving a new reading inside of here. So that's cool. My database is what is configured the sensor that's connected to my Pi. So let's do something cool. Let's add a new sensor to my database. I'm going to use the graphical tool here. Let's add a new row. Let's call this one DHT2. This is also a DHT22 sensor. This one is connected to pin 25 though, and then I need to commit this row. And now I'm going to run my program again, and let's see what happens. So notice this, I have 2 sensors now. So DHT1 and DHT2, and it picked up which pins they're connected to, and it's actually showing both of them. So if I breathe on this sensor, then we'll actually see that one of these jumps up. So this DHT1 sensor, it's going up to like 80% humidity, whereas my other one, it's not really changing much. So that's pretty cool. Like my program state is in the database, and I can plug in lots more sensors. I don't need to change any code. I just need to plug in new rows of data to this database. So pretty cool. That's a very powerful concept for structuring your programs and dealing with data here. And even though this is super simple, like it's literally just 3 columns of data, notice how it's not that complex to do this, in my code. I just need to write this SQL statement and then parse out the data that I get from it. So, I think it's worth this kind of effort in a lot of cases because, my program might get more complex. I might add different types of sensors, like beyond just the DHT sensor. And so I just need to add the code to read a generic, one type of sensor, and then I can plug in multiple sensors and just add them to my database here. So, okay, so that's cool. Now let's actually save these readings back to the database. So remember, I have that readings table where I want to add a row for each sensor reading inside of there. So let's do that. And again, I can just execute a SQL command inside of here to do that. So in my row, after I print out the sensor readings inside of here, let's get ready to add this measurement. Now, before I do this, first let's grab the current time. And I want to do this because for each of these sensor measurements, I want to make sure that they have the time that they were taken associated with it. So let's go through and we'll just kind of say, before I loop through each sensor, well, actually, how about, as I'm looping through each sensor, let's grab the time. We'll say reading time equals time.time. And so time.time is just going to return you back the Unix time in Python. So if I run Python and then import time, I'll show you time.time. And this gives you a floating point value, so this gives you like milliseconds and stuff. So this is the number of seconds since I think January 1st, 1970. Now, I only care about second level accuracy. I don't care about milliseconds and things like this. So if I just do integer time.time, then this is just going to drop the millisecond parts of this. And that's what I want to do in my code here. So we'll quit out of Python and we'll do that. So let's just grab an int time.time. So I'll use this to store, because remember my readings table, if I look at the column inside of here, the structure of this table, I have a time column, I have a name for my sensor, and then I have the actual sensor value inside of here. So I need all 3 of these values to insert them into this row for this table. So, okay, so I've got my time here. I've got the name of my sensor. That comes from the list of sensors that we're iterating through. And then I have my temperature and my humidity. And so I'm not going to try and jam both these readings in the same row. I'm actually going to save these as 2 different rows. And so I was thinking the name, I'll basically say my sensor name and then add humidity to that and then save my humidity value. And then I'll add my sensor name and then add, maybe temperature and save the temperature. So I'll show you that in the code here. So basically now I need to execute a SQL statement. So we'll say execute, and it's an insert statement. So insert into readings table the values, and then in parentheses here I need to give my values. Now, one big thing, so you might think like, oh, this is just a string that I'm making. So, I can just say, okay, let's just plus together, maybe the reading time value inside of here, and then let's plus, a comma, and then plus, how about my name of my sensor. But this is not a smart idea, and this got a lot of people, especially in the early mid-90s, even today, a lot of people get in trouble because of this kind of a syntax. So this is vulnerable to SQL injection, where basically, let's say this reading time value was something that I don't control. Maybe it was like a form that someone submitted from a web page. What if they put inside of here, what if instead of putting a time value, they hacked it and actually inserted something like, oh, let's just close this statement, and then how about drop table readings inside of here? This would happily run. This is valid SQL. My program has no idea what's happening, and someone has just gotten into my database and destroyed the data. They might create a new table and export it in some way. So very, very bad things can happen when you try and construct a SQL statement yourself without sanitizing the data. Now you can go crazy and try and string search and see, make sure it doesn't say drop table inside of there. But that you don't want to do that. So the people that created the Python library for this have thought of this problem, and there's a good convention. You can actually put in question marks inside of here. So if I put in 3 question marks, this is telling Python, okay, run this statement and then escape the values that I insert inside of here to make sure that SQL can't execute them. Even if someone tries to jam in a malicious drop tables, it's going to escape them so that they can't be processed as SQL. And then to actually give the values here, you actually just have to give a tuple. So you just give each of the values after this. So I'll give my tuple of values. So my reading time, my sensor name, and here I'm going to actually construct a new sensor name. And actually, let's put this on a new line. Just it's going to get a little bit long. And so here, let's do let's take the name of my sensor, and then let's do humidity as kind of my first reading here. And then I need to do format and give it the name of my sensor. And then for the last column, this is the actual reading, the value that I got back, and this is my humidity value here. So okay, so this is going to insert a row with the three values, the reading time, the name of my sensor, which in this case is going to be my sensor name plus the string humidity. So I know that this row is for the humidity measurement, and then the actual humidity value inside of here. And then it's using these question marks so that it's escaping the data that's going to be inserted in here. Make sure that you can't do bad things with the database. And then so let's just do the exact same thing to insert our temperature for this. So let's do this. And now let's change the name of this row to temperature. And then let's save my temperature value inside of here. So, okay, that's easy. And then there's one last little thing. So like I mentioned, you have to commit things to the database. So these changes have been queued up, but I need to tell Python that, okay, you can write these to the database. So let's do that now, and I'll show you the syntax for that. You basically need to go in and run this commit function on your connection, not on your cursor, but actually on your connection here. So we'll say, commit this. And so this is actually going to physically write the data to the database inside of here. So let's do that. Let's save this, and then let's run our program again, and let's see what happens. So, I did something wrong here. So let's see, syntax error, operational error. So I probably got something wrong inside of here. Let's see. So I'm giving it the tuples of my values here. So I'm giving it the reading time and the humidity. I'm formatting that string and the humidity there. That looks okay. Interesting. So it's mad about something in here. So it's mad about the values inside of here. All right, I'm going to cheat. I'm going to look at the code that I wrote ahead of time because I don't want to waste too much time inside of here. And by the way, I have this code up on GitHub, so we'll look at the part 1 code. Let's see, what did I do here that was a little bit different? So I have my reading time. I think I said value instead of values. There we go. Look at that. Just a little S that I was missing. Kind of nice. This the Atom text editor is what I'm using. Pretty cool that it's picking up that I'm writing SQL inside of here, and it kind of knows that this is the value that I actually wanted here. Okay, so let's run this, and now we should be able to see. Okay, so doesn't look like much has changed. But let's go back to our little SQL GUI tool here. This is connected to the same database. Let's run a query inside of here. So let's select star, and my program is still running. I'll kind of scooch this over. You can see it's running in the background here. Select star from readings. Oops, give the right name of the table inside of here. And let's see what we get. So hey, look at this. We've got some data inside of here. And there's quite a bit of data. There's 16 rows of data right now. And actually, if I run this again, we'll probably see there's more rows of data. So yeah, there's now like 44 rows of data inside of here. So this is cool. Like I've got one program running over here. It's writing a bunch of data. Like if I breathe on this sensor, we'll get a spike of data inside of here. And it's writing that data to my database, and then I'm using a little tool right here to query this data. But I could have a whole separate script that's running and querying this data. I could have multiple things that are looking at this data, and they're all looking at the same database. I didn't need to write some central data store that all my programs talk to. They're just writing to a SQLite database, and then using SQLite libraries and tools to read from it. And so it really simplifies my program a lot. Like you can see, all my program knows about is which database file it's talking to, and then the schema of that database. Like it needs to know what's the columns that I'm selecting from, or what's the the values that I'm inserting into that database table. And then it can get that data here. So this is pretty cool. Now I'll show you a little bit more that you can do with the select syntax. So it's pretty powerful. Like I was mentioning before, you can add a where clause where you can filter things. So like let's say I only want to get my DHT1 humidity values. So I can say, okay, where name equals DHT1 humidity. And then if I run this, now you see I only get my humidity values. But you can actually do something, you can do a fuzzy string search. So you can do where name like, and then let's say I just want to get only the humidity values from either the DHT1 or DHT2 sensor, because remember I have two sensors connected here. So I'm using this funky little percent sign, and that basically is like a star or an asterisk that says, okay, you can have anything before this, just match anything as long as it ends in humidity. Pull out the rows that end in humidity. And so if I run this, oh, that's cute. For some reason, the whole program just crashed there. So let's see, let me get this thing back here for a second. That is really funny. That's kind of wild. Yes, that is obvious that SQLite just crashed unexpectedly. So, hey, it's sometimes free software. There's sometimes bugs and things in it. So, okay, let's open our database again. Let's pick this. I have a feeling it's probably because I've got this Mac Fusion thing set up, and I'm reading this from my Pi remotely. This is probably not the right way. I probably should copy this database file to my machine here. But hey, we're gonna live on the edge here. So I've got my database open here. Let's go back to my query tool, and okay, let's just make sure I can select star from readings again, and then run that, and okay, good, no crashes there. Now let's do, okay, where my name is like, and then we'll give the string the percent sign humidity, and let's see if this crashes again. Hopefully not. Now when I run this, there we go. So notice here I get DHT2 humidity and DHT1 humidity. It's only the measurements that end in humidity. So that's pretty cool. That's pretty powerful. But you can go further. You can say, hey, let's do two things. So let's name like humidity, and let's put another clause inside of here. So let's do something with the time. And this gets a little funky. There's actually some really handy functions inside of SQLite at least. So there's some date functions, and I'm going to use this strf time. And when I use this with the percent sign s, and you can kind of read more here. This is how you get the Unix time, which is what I'm storing in the database. Like I can actually, if I go back to my readings table here and look at the data, you can see like this is the number of seconds since the Unix epoch. So if I go back into here, into my query, oops, and we lost it unfortunately. So let's select star from readings, where name like, oops, we'll capitalize that, percent sign humidity, and okay, so now let's do a query on the date, on the time basically. So, and I just want to make sure that I get the name of this column correct. So it is, oops, oh, I didn't have it here. What did I name that? I think it was time that I called it. I don't want to close this because it's going to lose. Well, here, I'll just copy my query. Let's go back and see what was the name of this. Oh yeah, so it's called time. Okay, so where my time column, and let's pick only the readings that were made in the last 60 seconds. And so that basically means where my time value is greater than or equal to, and then some numeric value. Now I could just manually put in, here's the Unix epoch time I care about, but you can actually call a function in SQLite. So they have the strf time function, and if I give it %s as a string, and then now, which tells it pick the current time, this is going to return back the current time in seconds since the Unix epoch. And I can actually subtract like 60 from that. So we'll take the last 60 seconds, and we'll just throw quotes around this just to be explicit about the order of operations here. So let's run this statement and see what happens. So, okay, this is cool. So, notice I only got 34 rows of data back here, but there are a lot more rows in my database here. Oh, wow, that's weird. I just hit the history thing. So, okay. So like if I run this query without this AND clause on here, let's just copy that out and run this, notice I get a lot more rows of data, hundreds of rows of data in here. And so, if I put this back, then you can see we're filtering more data. And so there's a whole set of Boolean operations. You can AND things, you can OR things together inside of here. So that's pretty handy, that's kind of useful. Another super handy thing, you can actually change how this data is ordered. So right now the data is just kind of coming back in a random order here, but let's order it in time, by basically the earliest reading first and the latest reading after that. So there's an order by clause that you can put in SQL, and I basically want to say the name of the column to order by, so the time column, and then you need to say either ascending or descending. And so let's do ascending. And so now I should see the earliest reading first and the latest reading last. So let's run that. And now we see, okay, here's a bunch of humidity measurements. And if we look at these values, so this is like 2582, 2591, 2619. So these are increasing, they're going up in values. And this again is super powerful. Like if in my program, if I wanted to render a chart and I wanted to get all this data in order, all I have to do is run this SQL query. My data is going to come back in the right order. The database is taking care of doing that query for me. I don't have to write the code to sort this myself because my code's probably going to be a lot slower. It's going to be done in memory. It's not going to be as efficient. So hey, let the database do it. Someone else wrote a really awesome database engine. Let's leverage it. Let's use it to our advantage here. So that's really all that I wanted to show for this first stream, is, just to get the basic idea of a database. It's not this scary thing that's, you're jumping into joining tables with foreign key constraints and, all kinds of crazy custom data types and stored procedures. Don't dive into that stuff. Keep it simple. Really, I just wanted to show how, if you think of data like a spreadsheet with rows of data, very easy to model that data in a database, and then it's really powerful. Once you have it in a database, multiple things can read your data. The database engine itself can do all the queries for you. You don't have to write a lot of this complex code. I mean, if you look at this code right here, this is a non-trivial program. Like, I can configure any number of DHT sensors, read their readings, and store them in some place, all with like 30 lines of code here. That's pretty cool. If I wasn't using a database, I'd have to have like some config file format. I have to like serialize this stuff to CSV data. And then when I wanted to query that data, I'd have to go write a query tool that reads that data. In this case, I can just pop open a SQLite query window, either a text window or a GUI tool like this, and let it take care of doing all that logic for me. So very powerful thing that's definitely worth checking out. And so like I said, I'm going to kind of continue this. I'll do another video in this series at least where we'll kind of go a little bit further and look at some tools that build on top of SQL and let you write Python code that's a little more descriptive and even more compact and simple, but still use a database internally. So we'll look at that, and maybe later on we might even look at some of that more advanced stuff that I kind of hinted at, of like, defining primary keys and foreign key relationships and joining tables, because that's where you really get into the power of databases. You can take things like, a hierarchy of object-oriented data, and you can model it as separate tables that all have relationships, and you can kind of recreate those relationships as you query data and get back, interesting things with that. So maybe later we'll look at some of that, but like I said, we're just going to kind of scratch the surface of a lot of this. So let's jump back to the main view here, and we'll kind of wrap this up. And if folks have questions, throw them into the chat, and I'll see if I can get to them. I noticed there are a lot of questions as I was going, so I'll see if I can kind of skim through this real fast. So yeah, people are wondering what I was doing. So like I said, this was, basically I was using SQLite, the really nice little simple database system with Python, and using it specifically to store sensor readings, because I was trying to think of a good context of like, what's something that, a Raspberry Pi project might want to do. So that's what I'm kind of focusing on here. Can you store down to the milliseconds in time? Yeah, you can, and I would definitely recommend checking out SQLite's date and time functions, and also their data types here, because ultimately, like, you could just store an integer, and that integer could be like milliseconds if you wanted, or you could use a real type and you could store your milliseconds as a floating point value inside of there. So you can totally do that. It just might change how you have to deal with interpret that data, and that's a big thing with databases. Like, you have to get over the initial hump of learning SQL and kind of learning that syntax, but really the reason why people who deal with databases are paid well, and why it is a full-time job for some people, is understanding how to model data in a way that a database understands is really pretty difficult. There are a lot of little gotchas and things, and really, especially understanding your database engine and how it stores data. You can get into a lot of complexity there for it. But don't worry, don't let that put you off either. Like you saw, like, you just keep it simple, like store text, store integer, store real, and if you put your data in that format, it's not going to be crazy. So, okay, a question of which sensors these were. Yeah, these are the DHT 22 sensors that I had here for this. So, let's see. And let's see. Oh, funny. Let's see. Yeah, maybe something. I think people were talking about when Alexa was going crazy earlier. So, okay, cool. So I think that's it. I don't see any other questions, so I'll wrap it up. This is a nice little live stream that I did. So if you haven't watched a lot of these streams before, I noticed a lot of people in the comments seem to be kind of new. So yeah, definitely subscribe to youtube.com/Adafruit. You'll see this video go up later, and then all kinds of other fun projects. Twitch.tv/Adafruit. That's where I like to stream these things live. So I like to do a lot of different streams. On Mondays, I like to do a Raspberry Pi quick look, I'm calling them, where I'll just look at interesting software. So I've looked at like Chrome OS on the Raspberry Pi, the OSMC Media Center, interesting new software. That's what I do on Mondays. Fridays on today, I like to do more in-depth streams like this, multi-part streams. So this is the first in SQLite for sensor data storage, and then next week I'll do another one. Now this Monday I won't have a stream again. It's Memorial Day, so hey, happy holidays for everyone. But I'll actually be down in Portland, Oregon for PyCon, the Python Programming Convention. So if you're out there and you see me, say hi. I'll be out there hopefully to learn a lot about distributing Python code. Just looking forward to kind of connect with the Python community. So no stream Monday, but there will be another stream on Friday next week. And then look in between. I'm starting to do more streams, like maybe a Circuit Playground stream on Wednesday or so. So we'll see kind of what happens there. So anyways, that's it. So thanks a lot for tuning in. Like I said, subscribe, like, comment, let us know that this is cool stuff, and we'll keep doing it. And again, thanks a lot. I was down at Maker Faire last week. Thanks for folks that came up and recognized me and said that they appreciate this stuff. It's really cool to get that kind of feedback. And if you want to see Maker Faire stuff, go to youtube.com/Adafruit. I have 4 different videos now. There'll be a few more videos of just neat things I saw at Maker Faire. So the one that I really liked, I did a 20-minute video where I walked around with a sound recorder and just recorded the ambient audio of Maker Faire. If you put headphones on, it's really cool. It was a stereo microphone, so you can kind of hear like all these conversations whizzing by. It's fun. It's a bit of a trip for that. So anyway, this is Tony from Adafruit. So thanks for watching, and I'll see you guys next week with the next part in the SQLite sensor data storage. So that's it for now. Thanks a lot.